Hello, everybody. Today I'm going to be talking about quadratics and more specifically about graphing with quadratics. So we're going to be doing a couple different things with the graphs. And because I'm not the most skilled artist, a lot of these questions I'm going to go through, these seven here, I won't really be able to draw out the graphs. So when I look at these, I'm going to have to use the explanations a lot. That way, they already have pictures of the graphs and drawn already for me. And so you guys don't have to try to decipher what my graphs will look like if I have to draw them with my mouse on the computer screen. It will look really bad and it won't help anybody at all. It'll make things more confusing. So I'm going to use a lot of their explanations, which also means that they already have a lot of the math written down. So instead of me writing it down as we go, I'll kind of be going through and scrolling through their explanations and talking about it. So that's also good news because this video might be a little bit shorter because you don't have to wait for me to write everything. And all the handwriting is going to look way better than mine. And if you want, there's different times where you can just mute me and read what's on the screen. And if you hate my voice so much, especially after a couple weeks of these videos, then you might enjoy this video a lot. So first thing we're going to talk about, it's finding the vertex, intercepts, and the axis of symmetry of these graphs. So you're going to have some questions just like these. We're going to go through 7 questions, and you guys have 14. You're going to pretty much do 2 of all these that we have here. So we have this parabola. Here's a graph here, and they're going to ask us these different parts, A, B, C, and D. They're asking if it's going to open upward or downward, if it where the x-intercepts, the y-intercepts, the axis of symmetry, and the vertex. So I'm going to talk a little bit about what each of these mean, and then we'll start getting into this specific problem. For a vertex is the point, the tip, kind of like where exactly this parabola turns around. So if this is coming up, 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 and it turns around, now it comes down. We're going the other direction as well. And so every parabola does that. This one is facing down, but if it was flipped and the parabola looked more like the letter U, it would go facing up, then the vertex would be down here at the bottom. The vertex can be all over the place, but there's only going to be one vertex right at the top or right at the bottom of wherever the parabola is. So the axis of symmetry, that's a line that goes right down the middle of our parabola. And for all of these, our parabolas are going to either open upward or downward. So that axis of symmetry is going to be a vertical line. It goes right down the middle. So wherever that vertex is, that vertical line that goes through it is our axis of symmetry. X-intercepts and y-intercepts, those are where the line crosses the x-axis or the y-axis. If you look on most of these parabolas, there's only going to be one y-intercept. It's only going to go through the y-axis in one spot. X-intercepts, most often they're going to be 2 different places. There's one here and one here where it crosses the x-axis. And if our parabola opens upward or downward, this one is opening down. It's kind of facing down where the open side is down. Whereas if it was upside down, then the open side would be up and it would open upward. So I'm going to look at this explanation and see how they kind of draw things out. So they give us 2 different showings of opening upward or opening downward. And they show us where the vertexes would be and an axis of symmetry that goes through those vertex right in the middle. And that way, if you folded this over on that dashed line, then your graphs would line up and they would match on top of each other. So on this problem, this one is opening downward, and the x-axis or the x-intercept on the x-axis, there's 2 over here at x equals -2 and at x equals 6. So at -2 and 6, we'll have our 2 intercepts, and they're at these 2 points, -2, 0 and 6, 0. Whenever you have intercepts, one of the numbers is going to be a 0. The y values are 0 because they are the x-intercepts, and the y value would be 0 on the x-axis. For the y-axis, for the y-intercept, the point where it is on the y-axis, the x value will be 0 and the y will be 3. So if you look, you can see that this crosses the y-axis at the number 3. And our vertex is up here at positive 2 for the x value and 4 for the y value. And our line of symmetry is on 2. It's that x value for the vertex and that line. So what's a little bit different is they write the line as x equals 2. So normally in function notation, we might have stuff like f of x equals, or we might have y equals, or we can have other like g of x or h of x or w of x. We have a lot of different letters that can switch around for f, but these would be normal ways we write functions. But this is x equals, and they're writing it as x equals because this line, this axis of symmetry, goes vertically. It's a vertical line, and so a vertical line is not a function, okay? A vertical line is not a function, so we have to write it as x equals the number. We can't write it as y equals or f of x because this is function notation, and a vertical line is not a function. So a parabola is a function, which is why a lot of times, let's see if do they have the equation written down here? No, they don't have the equation on this problem, but we'll look at the equation on some other ones. But when they have the equation for a parabola, they can write it in these ways, and that's okay. But for this vertical line, it has to be x equals 2, where that x value is. So this one, we're going to graph a parabola in this form, which is considered vertex form. So it's in vertex form, which means we should very easily be able to see the vertex. Just like how lines can be in slope-intercept form, and we can see the slope and intercept, this one we can see the vertex. So the vertex form is y equals a, in parentheses, times x minus h squared plus k. All right, where a does not equal 0. So you're never going to have a 0 in the front there. Sometimes it could be a -2, like this. Sometimes it can be positive numbers. Sometimes it can be a 1. Or if they don't put anything there at all, it means a 1 as well. So h and k have specific spots in this formula. So if we look at this formula and we look at the parabola they gave us, this equation, there are certain numbers that match those spots. So k is matched with this -3. So k is going to be -3. A is matched with this -2. So a is going to be -2. And 6 is +6, but h in our equation has a negative sign in front. So if h was +6, then when we put a 6 in here, we should still have a -6. So that means our actual h must be a -6. That way we'd have a negative in our equation, a -6, which would give +6. And if you look, they show that here with those two negative signs. So if it's h is a -6, then it'd be negative times a negative, which makes +6, which matches what's in the equation we have. So now we know h and k and a, and the vertex is written as hk. So our h is our x value for our vertex, k is our y value for our vertex. If we know h and k, then we can put our vertex at -6, -3, -6, -3. Now, for finding our vertex, that we're going to do a little bit more for, and we're going to make a table. Right? They already made the table for us, which means you're going to save a lot of time instead of me writing out this table. Let's see if I can erase those. Yes. So they have a table here. And what this table is, it has x values, it has our equation, our parabola, and then the xy ordered pair. So if I plug in these x values, any x values I want, I should get the y value that comes out. And where our vertex is, if I plug in the x value, -6, I should get -3. If I plug in -6 into our equation, I'll have this equation, which simplifies to -3. And they notated that because this is the vertex right here, -6, -3. But they want us to find 2 points on the left, 2 points on the right of our vertex. So if we're trying to find 2 points to the left and right of our vertex, well, if I think of a number line, ooh, that's a beautiful line, a number line or the x-axis, then if I had something at -6, I'd have to pick something to the right and something to the left. Well, if I just pick the next two numbers, like -7 and -8, those are on the left. And if I pick two numbers to the right, like -5 and -4, those numbers will be on the right. So if our vertex is down at, I'm going to use green, -6 and -3, so that's going to be down here. Well, however my parabola goes, it can be going up really steep, or maybe it's really wide. No matter what, I'm going to find two values on the left if I choose the next two values, -7 and -8, and the next two right values, -5 and -4. So what they did in that table is they put -6 in the middle. They put two numbers that will be to the left on the x-axis, and two numbers on the right. And when you plug those in, -8 goes in and gives us -11, -7 gives us -5, -5 gives us -5, -4 gives us -11. So now we have 2 points on both sides and the vertex right in the middle of our parabola. And if you notice, as we're doing this, because it's a parabola and there's a line of symmetry, it should be symmetrical. And if you notice, you can show that from these y values. These y values should be symmetrical. -11, -5, -5, -11. So now we have a bunch of points here, and we can plot those on our graph. So, oh man, I just realized I've been drawing this parabola facing up when really this parabola had a -2 at the beginning. That was negative, so I should have known that this parabola was going to open down. So now this parabola is opening down. They have their first point at our vertex, and these two points on both sides of our graph. So we've done those first two. Let's go to this third one here. So this equation is going to be written in a different form. Instead of vertex form, it's kind of more in the regular standard form, and which is how we see most of our problems anyway. So we're going to do the same thing. We're going to try to find the vertex and 2 points on either side. So that means we're going to use that table again, just like we did on that last one. But how to find the vertex is different because it's in a different form. Vertex form gives us the vertex very easily where h and k are. But down here, you'll notice that we have to use something different. So if this is in the form a, b, c, ax squared plus bx plus c, then we can use this little formula here for the line of symmetry. And just how we said the line of symmetry will have to be written as a vertical line, x equals a number. Well, if we write that as x equals a number, here we can use b over 2a, and don't forget that negative sign in the front, to find that. So we'll look at our equation for b and a. We don't need c for this one, but a is the number in front, which on this problem will just be a 1, and b is the number in the middle, which is a 6. So if you'll notice, they put 6 on top there where b is, and they put a 2 times 1, 1 where the a is. So now 2 times 1 is 2, -6 divided by 2 is -3. So now what they know and what we showed here is that our line of symmetry is going to be at x equals -3. And that line of symmetry matches up with the vertex because it's on that x value. So we already know half of our vertex now. Half our vertex is -3. We've got to find the y value for that. Well, if we plug in -3, the x value, we should get a y value out. Okay, it's equal to y here, right? There's a y there. So if I plug in -3 where all the x's are, which is what they did in this part here, plug it in and we should get a value for y. So -3 squared is going to be +9. 6 times -3 is going to be -18, +9, -18 plus 7 equals -2. All right. They didn't really write out all that work. They just kind of did it at once. And for you, since you're doing it on the computer, you don't have to show your work specifically either. If you want to do it all on the calculator, that's fine. So they found that -2 is the other half of our vertex. So now we have our vertex -3, -2. And we're going to make a table the same way, okay? And we're going to go 2 terms on the left, so 2 terms lower, and 2 terms higher. -3, -2, -1, -3, -4, -5. And when we plug those numbers into our equation for the x values, we'll get different y values out, and we'll get all these different y values to plot on the graph. So graphing from the standard form or graphing from the vertex form, this last part where we're finding these different points will always be the same, but it's kind of how we find the vertex at the beginning that changes things. If it's in standard form like that, we'll have to find the line of symmetry, x equals -3, and then find the y value for it. In the vertex form, it gives us the x and y value, the h and k, in that form right there. So we don't have to do this extra step to find the y value. They're going to give us both right at the start. So now this one's going to ask us to find the x-intercepts and the vertex of this parabola. So they gave us this here in standard form. And what we want to do is find if it's how many x-intercepts it has. So if you see here, they have 3 different examples. So these are the 3 different cases with parabolas. If a parabola is high enough on the graph, it might never touch the x-axis. So it'll have 0 x-intercepts, won't have any at all. If it's right just on the tip, just barely on the vertex is on the x-axis, then it'll have one x-intercept. But most of the times, the x-intercepts there will be 2 x-intercepts because our parabola will either be high or low, and it'll cross at the 2 different spots from this parabola. So with these 2, this is the most likely case. So most of the time, you're going to get 2 x-intercepts. So these x-intercepts, or the x value is a certain number, but the y value is 0. So what we can do is plug in 0 for y. So if our equation is y equals x squared minus 2x minus 8, put a 0 for y. If we put a 0 for y, now this part of the problem is finding the factoring and finding the roots. All right. Sometimes the roots are called the roots. Sometimes the roots are called solutions. Solutions, roots pretty much mean the same thing. So what they did here, they didn't really show all their work. I'm going to pause the video and show all of mine. So if I made my table and I tried to find 2 numbers that multiply to -8, add to -2, I would have to use 2 and -4, which would work out and be my 2 factors. And then my solutions would be the opposites of those, where x plus 2 equals 0, subtract the 2 to make it -2, x minus 4 equals 0, add the 4 to make it +4. So these would be my 2 solutions here. So those are the 2 x-intercepts, which this parabola doesn't necessarily match. This example drawn graph here, parabola, that one doesn't match our actual equation that we're working with. So we have these 2 x-intercepts. So now we just need to find the vertex. So it's not going to let me erase that. So that's going to be off on the side for a little while. So we have 2 different possibilities here. Either the parabola opens up or the parabola opens down. We have these 2 spots figured out. We need to know if it opens up or down. There's a quick, easy way to see that. Look at your first term. Whatever that letter A term is, that first term for the x squared, if it's positive, it's going to go up. If it's negative, it's going to go down. Positive or negative. Well, ours was positive, so it's going to open up. So now what we need to do is find the vertex. And so we can find the vertex a couple different ways. Since we have this equation, we can use what we did before and do the -b over 2a. But if you notice what they did is what they try to do is say, well, it's got to be symmetrical. It's got to be halfway between these 2. Okay, the vertex is always right through the middle. So what we can do is we can add these 2 points, the -2 and 4, add them up together, divide them by half, and that'll give us halfway in between, which will be on the x value 1. If you want, sometimes I don't use this little midpoint way. What I do sometimes is I just look on the graph and I say, this is at -2. I'll go over 1, over 1, over 2, over 2, and then over 3, over 3. Sorry, it's hard to tell with my drawing, but I just kind of count inward, going from the right and going from the left, and I just need to make sure that I'm right in the middle. If it's a small distance like these, I just count them up and it's 3 and 3, so I get to the 1 value from the middle. But if it's a really big parabola where you might have like 50 or 40 or 30 numbers in between, you might not want to count them all out. In which case, you can use this midpoint formula where you add up the two x-intercepts, you can add them up, divide them by 2, and that's going to be where if you look x equals y, that's going to be where our line of symmetry is going to be, right down the middle, which gives us half of our vertex already. And just like we did on those last problems, we'll plug in that value for x, and as we simplify, we'll get y equals -9. And now, down here for our answer, we'll have our intercepts -2 and 4, and our vertex at 1 and -9. And if you see from what some of the work they did up here, they also show down here, we also know that the parabola opens up because the coefficient for the x squared term is positive. That first term is positive, so that'll be our answer. All right. Maximum and minimum. So with parabolas, we're going to look for a couple different things. There's a maximum or minimum. They can't have both. If the parabola opens up, then it's going to go on forever, which means it won't have a limit. It won't have a maximum. It'll have a minimum, but it'll have a lowest point there. But if our parabola opens down, then it'll go down forever. So it won't have a minimum, but it will have a maximum. Okay. So if we know if it opens up or down, that'll give us our minimum and maximum. What they're asking for in these two boxes is where this minimum or maximum occurs. Well, the minimum or maximum is always going to be at the vertex. So the x value for the vertex and then the y value for the vertex is what they want. So on these ones, we got to determine, is it going to be a minimum, maximum, and find the vertex. And if you notice, this starts as a -2, which means negative number will have a parabola that faces down. So let's see if I can erase these and go to our, nope, just those. All right, I'm going to close this and open a new one. So new equation, same type of problem. Negative number, so that means it's going to have a maximum and it's going to be facing down. So, which is what they show right here. -3 is negative, so it's going to have a maximum value. Okay. Now we're going to look for is that vertex. X equals -b over 2a. We're going to use this little vertex formula here to find the vertex. This only works in the standard form, A, B, and C. It does not work in the vertex form because the vertex form shows it in the problem, in the equation. So A, B, and C are these three numbers from our equation. And if we plug B and A in, we'll have -18 over 2 times -3 with that negative outside. So now that means 2 times -3 is -6. -18 divided by -6 would be +3. With this other negative outside, a lot of negatives there, we'll have a -3. So our x value is -3 for our vertex. And if we plug in -3 into our equation, they showed here y equals f of x equals, because they've been showing f of x, but you could write it as y the same way. So whether it's y or f of x, if we plug in -3, it'll look like this. We'll simplify, and our y value will be 1. So now we have a maximum. We have our, I feel like they flipped those from the beginning. Did they flip those? Oh, I think the last problem they had them flipped. Either way, our x value for our vertex, for our maximum or minimum, the x value is going to be at -3, and our y value there was at 1. All right, this is domain and range. And I actually had a student ask me about this a little while ago. So I'm really glad that we're at this part in our unit where we can talk about what domain and range is, and I can show it very easily. So domain and range are the X and the Y values, okay? So if I think of domain as the X values, I'm thinking of all these X values here, okay? So you can see on our graph that we use these X values, okay? Our graph is on these X values right here. It's these positive Y on the top of the X axis. These ones are down here below, but we're using all these X values. Our graph uses all of these here in the middle, okay? But these arrows keep going. So if I kept going with that arrow, it would keep going and going and going and going. And so my X values wouldn't stop here. They keep coming, keep coming, keep coming. And since this goes on forever, all my X values to the right I'm going to use, and all my X values to the left I'm going to use. So I'm going to end up using all of these X values. Oh, and it won't let me erase. So I'm going to be using all X values. So what we want to put for our domain is all real numbers. Sometimes we can just put it as all reals. We'll look at the explanation to see how they write the answer. But they can put all reals. If you know it's going to use all the X values and just keep going forever, then you'll put all real numbers. And that includes all the positive numbers, all the negative numbers, and then all the smaller numbers and decimals and fractions in between. Okay, so I'm going to close this and open another one so we can get a fresh one to use for range. So we have this graph here. Again, domain will be all reals. It's going to go off to the right and off to the left forever. Okay, doesn't matter if they're on the top or the bottom, it'll always be going to the right and left. Now, for the range is going to tell us the Y values. Domain is X, range is Y. So the Y values, we have to go from all the way top and bottom, okay? And they go forever. So we have to look and see, does this go down forever? Yeah, so it's going to use all these different negative numbers. Does it go up forever? Well, no, this blue graph isn't going up any higher. It maxes out right here at that vertex. It has that maximum. So that maximum is at a -4. So we know that it goes all the way up to -4, but it doesn't go any higher. So that means that our range for our Y values, it's going to include -4, but we have to make a inequality, which is the greater than or less than. So we want all our Y values to be less than or equal to -4. Greater than would be above that. Our blue graph isn't above that, but it is below that. So we want less than or equal to -4. And I'll go to my explanation. And they don't let me erase. I'm just going to open a new one. So if we look at this one, we can say our Y value, the lowest would be, since it's facing up now we want those positive numbers, it'll be greater than or equal to -2, which is the lowest it goes. The domain will be all reals. Let's see how they write it here. They say domain's going to be all reals, go left and right forever. And this one's going to start at -2 and go up for our range. So they put all reals for domain, and range they'll put greater than or equal to -2. So if you don't have to put all real numbers, you can just put the words all reals. Now our last question here that we're going to go to is we want to find the equation of a quadratic function whose graph is shown. So we're going to start with a graph and finish with the equation, which is kind of opposite than what we started with at the beginning of this lesson. So if you can see, we already know the vertex, okay, and we know one other point. They plotted it for us. We could probably find some other spots that plotted, but we have these two that they gave us. That'll be good enough. So let's write this in vertex form since we have the vertex. Vertex is H and K. So on this problem, it's 5 and 5. So I'm going to put in a 5 for H, 5 for K. And now my equation will look like this. So all I'm missing now is my a. So to find my a, I'm going to use this extra point. So what I'm going to do is if f of 6 equals 2, 6 is the x value, 2 would be the y value. So if I plug in a 6, I should get a 2, which is what they are showing here. Plug in the 6, I should get a 2. So we're going to use x equals to 6 and f of 6 equals 2. So instead of having an f of x over here, we're going to have a 2. And instead of an x in the middle, we'll have a 6. Okay, we'll replace those with 6 and 2. And now when we do that, a is the only letter that's left, so we can solve for a. 6 minus 5 is 1. 1 squared is 1. 1 times a is a. We have plus 5, so if I subtract 5 from both sides, then we'll have negative 3 equals a. So now we can take this equation and plug in negative 3 into that spot. And so now our equation in vertex form that started with this graph will end as f of x equals negative 3 in parentheses x minus 5 squared plus 5. So you should have the availability on all these problems when you are working on them to use those explanations and use those hints and help on this assignment whenever you do it. That's totally okay with me if you use it. I don't think you get credit for the problem once you use it, but you can redo the assignment and redo those problems. If you needed to use the explanations for help, you can redo the problem. And when you redo it, you only have to redo the problems you got wrong. So if there was 14 questions on this assignment and you only had to redo one of them, you won't have to do all 14 again, just the one you got wrong. And I can see Elizabeth Moreno is emailing me, so I'm going to stop my video and try to talk to her and see what's going on. Have a great day, everybody.